Good morning, friends. Under chemical kinetics, we have looked at the various options where we studied the factors affecting the rate of reaction. Now, in that, we very well know that the factors which affect the rate of reaction are primarily concentration. They can also be temperature, they can also be catalyst. Secondly, the rate constant or the rate expression, they are also the factors they are also the factors which affect the rate of reaction. At the same time, order of a reaction and molecularity of the reaction are two other factors which affect the rate of reaction. Now today we will first look at what is order of a reaction. Now, as per the rate law or as per the rate expression, we know that the rate is given by the reaction. The rate is given by the equation rate is equal to K into concentration of A to the power X into concentration of B to the power Y. Now, we have derived this on the basis of the general equation, which is small a capital A plus small b capital B gives small c capital C plus small d capital D. Now, on the basis of that, we have identified the rate expression is given as rate is equal to K into concentration of A to the power X into concentration of B to the power Y, where A and B are the reactants respectively and the exponents, that is X and Y, they may or may not be the stoichiometric coefficients, and here K is called as the rate constant. Okay, so X and Y, that is the exponents. Now these exponents ideally indicate that they are very sensitive to the change in concentration. So if the concentrations are changed, then the exponents, that is X and Y, may also change. Now order of a reaction is given as we have already discussed this earlier in the class also, that the order of the reaction is given by adding the exponents X and Y. So when the exponents X and Y is added, you get the order of a reaction. So we have also looked at the definition of the order of reaction, which states that the sum of powers of the concentration of reactants, the sum of powers of the concentration of reactants in a rate law expression is called as the order of the reaction. So order of a reaction can be 0, 1, 2. Okay, and it is a experimental, or it is an experimental value, and it can also be a fraction. Now generally reactions, if we see, generally reactions do not complete in one single step. Not all reactions complete in one single step. That is, therefore, a balanced chemical equation, the chemical equations or the stoichiometric balancing of chemical equations does not actually give us a true picture about how the reaction might have completed. Okay, so there are reactions which complete in one step, there are reactions which complete in multiple steps. Now the reaction which completes in one step are called as elementary reactions, and the reactions which complete in multiple steps are called as complex reactions, and the steps which are included in the complex reactions are called as mechanisms. Okay, so there are certain reactions which undergo various steps, and they give us and it is actually these steps are nothing but the mechanism of the entire reaction. So here we have an example where we have given combustion of ethane gives water and carbon dioxide, and the water in the water in this reaction, it passes through many intermediary phases, and these intermediary phases involve the formation of aldehyde acids and alcohols. So these intermediaries, when the intermediaries are formed, we particularly say that the intermediaries would actually define the intermediaries would actually define the mechanism of a reaction. Now secondly, we can look at the unit of rate constant. Okay, so we can calculate this. We can calculate the unit of rate constant very easily. It is a mathematical term. When we look at the derivation, you can automatically go ahead and understand it. I will just take you through it quickly. We know that rate is equal to K into concentration of A to the power X into concentration of B to the power Y. So K is equal to, so mathematically K is equal to rate upon concentration of A to the power X into concentration of B to the power Y. So if concentration of A is equal to concentration of B, so let's term this entire as concentration. So then what will it become? K is equal to rate upon concentration to the power N, where we have added X plus Y, it gives us N, and N is nothing but the order of the reaction. Now we know that rate is given as concentration upon time, because we have studied about this already. So rate of change of concentration with time would give us the rate of a particular reaction. Okay, so therefore we can rewrite this as concentration upon time into 1 into concentration to the power N. Now what is the unit for concentration? We know it very well that it is mole per liter, and the concentration of time is and the unit for time is seconds into 1 upon we can put it as concentration again mole per liter. Now that N, that becomes order. So if N is equal to 0, then for a 0 order reaction, let's check what the unit can be. For a 0 order reaction, the unit can be mole per liter upon seconds into 1 upon mole per liter, the whole to the power 0. Now here when we have put, when the exponent is 0, as per the law of indices, we know that this is equivalent to 1. Therefore the unit for 0 order reactions will be mole per liter upon seconds. So we can always write this as, or we can always tell it as mole per liter per seconds. That becomes the unit for 0 order reactions. Now what can be the unit for a first order reaction? Again the same thing, mole per liter upon seconds into 1 upon mole per liter, the whole to the power 1. So that means here mole per liter and mole per liter can get cancelled. What will remain? 1 upon seconds. So we can say that S to the power minus 1 will be the unit of first order reaction. Similarly, when we look at the unit for second order reaction, in case of second order reaction, what will happen? We can always write it as mole per liter upon seconds into 1 upon mole per liter, the whole to the power 2. So then 1 mole per liter will be cancelled each. In that case, then what will be the answer? The answer will be mole per liter. The answer will be mole to the power minus 1 L, because L is minus 1. When L goes to the top, it will be a positive value, mole to the power minus 1 L, and S to the power minus 1. So that will be the unit for second order reaction. You can again go ahead and find out the reaction for the unit for the third order reaction. For third order reaction, only thing is you have to put the exponent as 3. When you put the exponent as 3, you can cancel it with 1 mole per liter, and entirely this equation will be mole to the power minus 2 L to the power that is L to the power 2 and S to the power minus 1. So that is mole to the power minus 2, L to the power 2, S to the power minus 1. You can check it out. This is a mathematical term. You can easily calculate it. Okay. In the next video, we will look at the molecularity of a reaction. Thank you.